Element 31 on the periodic table is known as gallium. This is Norris Teaches Science with another Physical Science Edition video with me, Mr. Norris. We're still talking about physics stuff with this video. Unless this is the first video you came to, then maybe you should go check out the other ones. I'm just saying. All right. Today we're going to talk about force, and by the end of the video, you should be able to say I can calculate the force exerted on an object based on Newton's 3 laws. So what is a force? Like I usually do, we're going to start off with the definition and expand on that definition and that topic. So a force is a push or a pull on an object. You can push on a wall, you can pull on a door, anything that's a push or a pull. Now, it can cause resting objects to move. So say, pretend that there's an empty water bottle at the corner of your desk, and I come around and I just smack that water bottle across the room. Caused it to move. I do that in class, actually. And it can cause moving objects to accelerate, kind of like when you hit a baseball. It was moving, and now it's moving in a different direction, but it used force with it. Now, there's two main types of forces. You have balanced forces and unbalanced forces. So balanced forces involve two forces. They're in opposite directions. They're both equal, so what's going to happen is there's going to be no movement, or it's going to be stationary. Unbalanced forces, there's two forces. They're in opposite directions, but one is greater than the other, and unbalanced forces cause movement. This is, you can think of like tug of war. If you're doing tug of war and no one is making any headway, you have balanced forces. But if you're playing tug of war and your team pulls the other team over the line, then there was unbalanced forces in your favor. Now let's talk about Newton's 3 laws of motion. So the first law of motion is called the law of inertia, or object at rest will remain at rest, or objects in motion will remain in motion unless acted on by a force. All right, so a water bottle in the corner of your desk will stay in that corner of the desk, not moving until a force acts on it. Or say you have a spaceship in space. It's going to keep moving forward until another force acts on it to change its direction or cause it to stop. So it's called the law of inertia because inertia means the force that is resistant to direction of motion. So the whole concept of the first law of motion is unbalanced forces. It's about movement. So examples, again, scientists call them inertia belts, but seat belts. A seat belt in your car stops you from moving forward when you apply the brake, because you're just applying the brake to the car. You're not applying the brake to you. The seat belt stops you from moving forward. And again, a spaceship going through space, just a little slight motion of the spaceship forward will cause it to keep going forward until it is acted by another force. The second law of motion, the law states the acceleration of a body depends on the ratio of the acting forces to the mass of the body. I know, that's really interesting. What it is, it's the force formula. It's how we calculate force. And the concept is all about unbalanced forces. Again, we're talking about things moving. So the force formula, algebraically, you would say force equals mass times acceleration, or capital F equals lowercase m times a. Now, mass, we know how to is usually given, and we learned how to calculate acceleration, but luckily for us, in these formulas, in these examples, acceleration is going to be given to us saying this is the acceleration. We won't have to calculate acceleration and then calculate the force. If you get into like physics and higher level sciences, you'll have to do multi-step problems like that. So the capital F represents force, and the unit for force is known as Newton, developed by Sir Isaac Newton. All this stuff about force, so why not give him credit by giving him the unit? Mass, the little m is mass, it's going to be kilograms, and A's acceleration, its unit is going to be meters per second squared. This is algebraically. Again, I like to use the triangle method. So since mass and acceleration are being multiplied, we're going to have to place them next to each other in the formula, because that's how, in the triangle, because that's how they work, because things next to each other multiply, things on top get divided. So M and A at the bottom and F at the top. Let's do two problems. It says how much force is needed to accelerate a 50-kilogram car at a rate of 4 meters per second per second. So we're trying to find force. We have a value here and we have a value here. So in the formula, the first thing we do, we place the letter of what we're trying to find. Since we're trying to find force, force is represented by the capital F. Capital F goes at the top. Now, at the bottom, we have our mass, which is 500. And then we're also going to have our acceleration, which is 4. Since the numbers are next to each other, we're going to multiply them. And that means we're going to get 2,000. But you need to give the unit for force, which is newtons. And that is solving this problem for force. I pause this video right now. This is the second force problem. I want you to pause and try it on your own. Did you try it? Did you pause? Are you just waiting for me to give you the answer? How are you going to learn anything if you don't do stuff on your own? I'm kind of joking, but I'm not really joking. I am being serious. So do it. All right, I'm gonna go over it now because I don't want to waste any more time. I mean, I could waste all day, all the time you want today. I digress. Let's get back to this. All right, a 50-kilogram object, so 50 kilogram, is accelerating at a rate of 2 meters per second squared. What is the force that has caused this acceleration? So we're trying to find force, so we're going to leave F at the top. We have our mass of 50. We have our acceleration of 2. All right, we multiply it. We get 100 as our value, and then we have our unit of newtons. All right, so that was the Newton's second law of motion, but remember there were 3 laws. So the third law of motion says, for every action, there's an equal but opposite reaction. So the concept here is all about balanced forces, about not moving. So stationary objects, what if you look at something that's stationary around you, there's a force acting down on it, but there's also an equal force acting up on it, so it stays where it's at. Or you can think about rockets being launched to space. There's a force pushing down on the ground, causing the object to accelerate into space. Now remember, forces are equal but opposite with this law. Equal but opposite. So let's apply it. So if Rico kicked a ball with 100 newtons of force, so Rico exerted 100 newtons of force on the ball, how much force did the ball exert on Rico? Remember Newton's third law. For every action, there's an equal but opposite reaction. So that would mean the ball exerted 100 newtons of force on Rico. And that's a little bit about force in the guy Sir Isaac Newton and all the stuff he did with force that we're going to cover in this video. I really hope you learned something. I'm Mr. Norris. I'm out. I'll see you at the next video.